In this last little video, and this is a lead into what we're going to be doing in the next section, what if x and y are both functions of a third variable, z? So x is a function of z and y is a function of z. And what if we want to compute the derivative with respect to z? Now, here's the way this works. If a term involves only z, then the derivative is as usual. So this is we want to find the derivative. We want to find dx dz and dy dz. This is the independent variable, right? Z is the independent variable. And so if it only involves z, then the derivative is as usual. This is 8z to the third on the right-hand side. That's no problem. But now, x is a function of z, y is a function of z, so anytime you do the derivative of any variable other than z, you need, the way to think of it is d that dz. And so the way that works is this. So this is 6x to the first, but we need dx dz, because z is the independent variable, no matter what any other variable has. And then this is 12y to the second, but now we need dy dz. Now the difference is this: if we have multiple variables, and we will see this when we get into the next section, if you have multiple variables, then you do not need to solve. You do not need to solve. Just leave it like this. And so we can take, what if they're both functions of z? And so if they're both functions of z, then we want dx dz, dy dz. If there were a w in here, we would need dw dz. If there were a t, we would need dt dz. And so if everything is a function of z, then we need d that dz, d that dz. The only time you don't need this differential is if you're computing the derivative of a term that only involves the value z. Now, what is perhaps interesting, depends on which side of the camera you're on, the equation you start with might not even have a z in it. I might have w squared plus x to the third minus y to the fourth is equal to 8. And we want to find the derivative with respect to z. By the way, this is preview of Calculus 3, if you're ever going to hang around that long. The derivative of w is squared is 2w. I need dw dz. Now, how do we know we're using dz? Because that must be given in the problem. That must be given in the problem. dw dz, and then this is 3x squared dx dz. And then this is minus 4y to the third, dy dz, and then the derivative of a constant is 0. And then you do not solve for any of them. Why this is important and why this is done, we will see in the next section. We're going to do several problems like this, and it will become very clear why this is done this way. So that's our investigation into implicit differentiation, finding dy dx, and then finding with respect to some other variable, which actually might not even be involved in the equation.